Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at the values of K, that is equilibrium constant. And what does it tell us in terms of the formation of product or reactant at equilibrium? So that's the one thing you have to remember. It is talking about at equilibrium. Now let's look at this particulate diagram. Now we use the word particulate diagram. Think of the word particles, okay? So we draw particles to represent what's happening here. In this case, at 0 second, you notice we have reactant, yellow and blue. Over time, those yellow and blue react to make the product. And look what happened. Continue to 200 second to 300 second. You notice starting at 200 second and 300 second, it looked the same. So that means right here we have equilibrium. As you can see, there are no changes in the number of product or reactant. So that's one thing you have to remember when we look at particulate diagram. When does a chemical reaction achieve equilibrium or establish equilibrium? Now, with that information, let's go back in here. When K is equal to 1, the formation of reactant and product are equally favored. And that means the number of products and the number of reactant, again, we are talking about particulate diagram. You are going to see that the number of reactant and product are the same. So because they are equally favored, okay? So again, we are talking about the condition at equilibrium. So when K equal to 1, remember, equilibrium is pretty much over product over reactant. So of course they are the same, equal to 1. Now let's talk about where K is greater than 1. So that means we are increasing in K. So what is really happening here? Well, think about it. If K is greater than 1, the only way that's work is that product increase or reactant decrease. So that means we have more of the product. So by looking at the equation, we already kind of determined what it's going to be. And look at this. The concentration of product are large, okay? The product formation is favored. And if that's the case, we would have more product than reactant. See how that is? So let's go to the other way around where if K is less than 1. And the only way that works, if we look at K, again, term of product over reactant, you would have a lower product, right? Because again, the lower it is, when you divide it, you will have a value less than 1. So if that's the case, you can say that the product is small. And here's the tricky part. Sometimes they don't use the exact wording as we use it here. They use it in terms of reactant. If that's the case, the reactant is more, okay? So be careful with the wording. While for consistency, we use the term product. So the product is small. Therefore, the reactant formation is favored. Now, a lot of time they are giving you a particulate diagram. You have to determine the values of K relative in terms of equal to 1, greater than 1, or less than 1. So if that's the case, in this case, if K is less than 1, you will see fewer product than reactant. So that is how we look at the values of K and make an estimated guess of in terms of which is favored, either product or reactant at equilibrium. Again, we are talking about at equilibrium.